you can write it. You can write it on the message and on the chat box, and then I can I can ask it again to the presenters after the presentation finished. So please do not hesitate to write your questions. And since we have only 5 minutes for questions, we might not be able to answer all the questions. So please do not, we will continue virtually by contacting the presenters. So yeah. I suggest we start directly to the first presentation, which is about a review of innovation in techniques used for coral reef restorations, the case of Kenya. It is presented by Omar Farouk and co-authored by Frederic Thamuth and Juliette Carissa. Okay, Eunice, how?
I'm here. Yeah. I think Omar is
presentation
not,
ready.
Omar is not here, and we haven't received it before.
Okay.
I would be happy to jump in with the second presentation if you want me to. It's up to you.
Yeah,
Andre.
Yeah. If Juliette doesn't have any infos as a co-author, then we might have to switch the talks, and I can try to figure out.
No, I didn't get any communication that the last time we talked, he was going to present. So
okay, then I would
so
suggest
we can move to the second presentation directly.
Sure, no problem.
You wanna share yourself, Andre? I assume.
Yep, I can do that.
Perfect.
Second here.
Yes, we can hear you, and we see the.
Yep, can you see that? Excellent.
Yes.
Perfect. So yeah, thanks for having me today. It's great to be part of Biogen and the network that to participate in this network. So I'm very glad to be here. Yes, so I'm the regional manager for Europe for Innovacy fish tracking, but that doesn't mean we don't do any knowledge transfer in other areas like the Indian Ocean, and I'm also looking after some projects in the Middle East and so on. So it's not directly only Europe that I'm working with people on projects. So I'm going to talk about real-time data as this is a really innovative technology in terms of fish tracking, but also environmental monitoring. So as I've got only 10 or 15 minutes, I jump right in. So Innovacy we consider it as a 360 degree on aquatic solutions in general. So on the right-hand side, you can see aquatic species tracking is one component of what we do. Environmental monitoring or sensing is a different component. And then on the left-hand side of this slide, you can see that we also do a lot of things in aquaculture, land-based and offshore. So this is where all of our technologies kind of come from. We have been around for quite a while, 40 plus years of a track record in designing, manufacturing, and delivering these acoustic telemetry and environmental sensing products worldwide, also in the Indian Ocean. Our technology provides the tools for monitoring and positioning of fish to study various aspects like survival, predation, overall behaviors, and the movement in basically all aquatic environments. It's not dependent on one particular environment like the marine environment, the ocean, but also in lakes and rivers and so on. And we also do one other part is consulting. So we help people with data analysis and all sorts of project related components like project design, but also carrying out tagging of fish, deploying gear, whatever people need, or we can do studies from A to Z as well. So we do everything, including project writing and report writing and so on. So what is acoustic telemetry? Very basic knowledge that I want to transfer here. It's based on a transmitter-receiver principle. So there's a transmitter sending out an acoustic signal underwater, and that's picked up by receivers, let's say. So we've come a long way. As I said, we've got a track record of about 40 plus years, and acoustic telemetry has originated somewhere in the 70s. So it was very cumbersome equipment in the beginning. Then with miniaturization and technological advancements, now we've got really small tags. We can tag animals that are like 6 grams in total weight. We've got real-time data possibilities and so on. And so with that, with those advancements in technology, lots of people pick these technologies up in various parts of the world. As you can see here, this is a review of Hassi et al. In 2015. So it's a little bit dated now, but you can see that basically acoustic telemetry has been used everywhere around the world. You've got some hotspots, obviously, and it all comes from North America. Innovacy is based in the US and in Canada, and all of our acoustic telemetry production is happening in Halifax on the east coast of Canada. So you can see lots of studies being in North America where this technology has been developed and initiated, but it's happening all around the world. There's different types of acoustic tracking. And again, this is very brief what I'm doing here in these few minutes. We've got an active tracking component where you can actively track fish from a boat, for example. Well, then we've got passive tracking. It's static moorings that are listening out for tagged animals that are in the vicinity of those moorings. And then we've got real-time tracking, also static moorings, but they relay those detections in real time. And I come to that in a little bit. So yeah, that's what we're going to focus on today, real-time tracking. Study examples. So I have to minimize this bit. Study examples. So as I said, we work in all aquatic environments. That's lakes, rivers, estuaries, and the ocean. And these examples that I'm giving here, they're not bound to a particular aquatic environment, obviously. Spawning behavior can happen in lakes and rivers and oceans. So these are just examples to show you what kind of applications are possible, I guess. Climate change related issues together with pollution impacts, distribution and habitat use, survival, fish passage, mainly in rivers around hydropower stations, as you can imagine. Migration timing is very important if you look at trout, salmon, and so on, and related industries, but also anthropogenic impacts of all sorts, invasive species in various environments. And if you then, this is the slide where I highlight MPAs and estuaries and oceans. You've got nursery areas probably in estuaries, mangroves, and so on, migration behavior in general along coastlines, feeding habitat, other habitats that are important to certain species, MPA effectiveness, site fidelity, home range, predation impacts, whatever you can think of, and there's many, many, many more. We've got 3 telemetry systems in place, and I'm going to focus mainly on the 69 kilohertz frequency today, just because it's that's the frequency that's mainly used in the ocean when you look at far-ranging animals, long-term migrations, and so on, but all sorts of other applications as well. So the higher the frequencies here, the better the work in shallower freshwater or noisy environments, just to mention these other ones as well. So with advancements in the hardware that people are using, software needed to be developed alongside with it. So now we've got a new software suite that's called Fathom, and that has got different aspects to it. I can't cover them all here today, but what I want to get into is Fathom Live, obviously, the live data application. And I show you a quick video that we produced, so that gives you a little bit of an overview. I'm going to talk over it, so I'm going to minimize. Can you still hear me? Okay. I hope so. Anyway,
yes,
so
we can hear you.
Yes, we can.
Perfect. Okay. I just turned off the noise of that video. So basically, this new software lets you use a mobile app on your tablet or phone, where you can record any kind of metadata in the field. You store it right into the cloud, and it's always available for you to store, but also to access later when you want to analyze your data. So there's a little fishy being tagged, it's going past these stations, and all of this data is then, it can be relayed real time, and that's what we focus on here today. You can visualize animal movements in certain areas where your moorings are situated. We call them hubs, and these hubs will then relay the information to the cloud, and it can be visualized on your desktop or in your desktop, basically. So in Fathom Central, that's where all the data comes together. You can share your data with networks as well as you like. So it's really easy to share data with other people if you want to. Fathom Position is another component where fine scale positioning is possible of your animals that are moving around a certain area that you're interested in. So again, these different components, Fathom Live, Fathom Mobile for the mobile apps, Fathom Connect to communicate with your equipment. Fathom Central is the hub where all your data goes to, and so on. So yeah, it's just a brief overview here. Fathom Central, as I said, it's basically now your data hub with all related topics to data. It's really easy to use. It's always accessible to you. Fathom Live, we've got real-time data. It's not only Fathom Live. We also have cabled versions of our equipment, of these receivers. When you're working close to shore, you can use cabled versions. But if you're working further offshore or in remoter areas, you can use these hubs, these buoys that work with Wi-Fi or the mobile phone connection, and we're working on a satellite version for this as well. So you can get your detections and your environmental data with a hub into this surface unit, and then data is relayed to your desktop. You've got secured access to what we call your dashboard on the top right here, and you can see all the detections coming in tiles. You can visualize it in different ways and so on. So it's a really nice way to access your data remotely in this way. Aqua Measures are our pods or equipment that we use for environmental sensing, and those are compatible with our acoustic telemetry equipment, so they can communicate with each other, or the data that is collected on environmental sensing variables can be relayed to the receivers, or you can download them via an app as well, the Aqua Measure app. So this is how it works. We've got different sensors that you can use, DO, dissolved oxygen, for example, salinity, and POD or pod. It's basically every other sensor variable that you can think of: blue-green algae, chlorophyll, turbidity, whatever you can think of, dissolved oxygen, dissolved organic matter, and so on. So we collaborate here with Turner Electronics, and basically all of the sensors that they've got available, we can add to these Aqua Measure sensors. When you download your data via the app, it looks something like that. So you've got a graph or a timeline of your dissolved oxygen, for example. This is the variable that you're interested in, and you can see that how it's evolving over time. And temperature is always one variable that is included in those environmental sensing pods as well. So as I said, you can couple those acoustic telemetry equipment with Aqua Measures, so you can get real-time data on animal detections, but also on different environmental parameters in real time. When you then overlay your data layers, your animal detection and your environmental variables, you can not only answer questions related to where and when an animal has been in a certain area, but also why. And so that gives you a different depth of the questions, or a different layer to the questions that you would like to answer in your particular project. I would like to give you one example where real-time data is used at the moment in a fairly extensive way. This is happening at the east and west coast of Australia. And here the fishery departments have decided to tag certain species on the east coast here, that is white bull and tiger sharks. To date, they have tagged more than 700, almost 800 sharks, individual sharks in this area. And then they've got different stations along the coast where these animals are being picked up. Why do they do that? Because there's a big overlap of the use of humans and these particular shark species around beaches, lots of swimmers in the water, lots of surfers, and so on, lots of recreational activity. So they wanted to know, when is it important to close a certain beach, for example? You're not only looking at the water or if there's a shark attack happening, but now the public safety is alerted within 60 seconds when one of those tagged sharks is being detected. That doesn't mean it's always safe to swim there, but at least where they're continuing their tagging efforts, obviously, and they want to tag as many sharks as possible at the moment. So they developed this Shark Smart app, where then you as a swimmer, surfer, you can access this data as well online. So it's not only there for researchers as such and for scientific research, let's say, but it's also there for public. It can be on public displays such as these apps, but it can also be, you can imagine it in some kind of visitor centers, for example, where you are interested when a migration is happening of salmon or eels, for example, where people are interested, okay, now, these species are starting to move past this particular spot in the river or estuary. So there's lots of different ways how you can use this data eventually. So if you do have any questions, let me know, shoot me an email. We can always organize chats. And one of my main aspects that I'm dealing with is helping researchers and people, biologists mainly, obviously, but also sometimes engineer, with developing ideas, projects. We work on project design together. We have a look at which equipment works best in your particular case for your research question. And we do a lot of knowledge transfer, not only during conferences and meetings like this, but also we host a lot of workshops, regional workshops, local workshops, webinars. And obviously, well, I always think that in-person meetings are always more valuable. So when you can touch the equipment and you can get a feel for the equipment, how it looks like, and we can have a look at some data and visualizations together of this data that people are producing, together with all the background knowledge that people might be interested in, then we organize these workshops for free as well. This is kind of our customer support, and I'm always happy to discuss that with anyone who is interested within this community, especially as well. Thank you very much. I'm looking forward to some questions, if you like.
Thank you very much, Andre, for these very interesting presentations and interesting theme also. Any questions in the audience? You can unmute your mic directly and speak if you have any questions, or write in the message box.
Yeah, maybe from my side, if there's nobody else at the moment. Thanks, Andre, for this really interesting talk. When I was monitoring coral reefs, I was really intrigued about the idea of some sort of integrated sensor system. How does it work? Do you offer like a one-stop solution where a research institute would approach you and talk to you about the idea they're having, and you would basically then implement what you agreed on, or would you like sell or rent those sensors and help them with setting up the whole thing that they planned?
Yeah, we are very flexible in this regard. Usually, how it usually starts is that people contact us or me directly, and they start talking about an idea. You know, we want to have a look at, you know, coral reefs, for example. We stay with this example, and you say we want to monitor fish behavior around a certain, you know, coral reef or different reef systems, and how can we best do that? And we are also interested in different sensors, and so then we kind of develop what kind of equipment would work best. And then sometimes, in very rare occasions, we rent the equipment out to people if they like to choose to go that way. But usually people are buying that equipment as kind of an infrastructure. Let that be environmental sensing equipment, which can also be working as a standalone unit. You don't have to do acoustic telemetry or environmental sensing. You can do it both, or you can do it separately. So it really depends what you are interested in. If you're only interested in environmental data, you can use these Aqua Measure pods separately, and you use your mobile app while downloading your data that way, and then you can, you know, model different things. But yeah, usually people buy that equipment as part of the infrastructure. You know, it's a very long-lasting equipment. It can last, you know, for more than 10 years easily. And so once you buy your equipment, you just have to re-battery most of the equipment. If you use transmitters that are attached on animals or within animals, they are sealed off units. They last for a certain time, depending on what kind of transmitter and the size and the model that you're choosing. It can last from half a year to 10 years, for example, that you can track animals for. So the bigger models that we've got in place are mainly for far migrating animals, long-lived animals. They can be, and I talked here mainly on fish. Sorry, my camera is somehow skewed in here. So now you can see my face as well, which is better. So I'm talking mainly about fish here, but what it really is about is it's about aquatic species. We've got people tagging anything from sea stars, sea turtles, conches, sea urchins, all sorts of fish, up to whale sharks, really. And so, and anything in between, cephalopods as well, mussels, oysters, whatever you're interested in, you can tag. Wherever you can attach a tag to, you're probably able to tag as well.
Yeah, thanks for sharing. I think it's a highly interesting technology also for the region. Sorry, Gil,
Yeah.
I'm done.
No worries. No worries, Hauke. I think we still have a few minutes more because we have one presentation list. Thank you for the answers. You already answered one of my questions also. But okay, maybe I would ask about you know, the accessibility, the prices of these sensors. So what is it about? Can you just because, you know, for example, I saw in the map it is mostly in the developed countries. Is it something because it's very expensive, or is it something that applicable we can buy here in the YO, for example, for a smaller budget, something like that?
Yeah. First of all, it's a very scalable technology, so you can start with a few units if you like to, and, you know, concentrate your efforts on a small area like an MPA or a reef patch or something like that, or an entrance of a river to the ocean. So Yes, if you look at fish tracking, other fish tracking technologies like pit tags, radio telemetry, or other sorts of looking at fish movement, yes, they are cheaper to start with, but the depth of knowledge that you can gather from this innovative technology like acoustic telemetry is a very different one. You know, with pit tags, for example, pit and antennas penetrate the water to like 30, 50 centimeters, right? So you can see in shallow waters or at like bottlenecks at hydropower stations, for example, yes, you can see when an animal is passing this particular small scale environment. If you look at radio telemetry, it's a bit more versatile, but again, these antennas, you know, the antennas can, or the transmission can only go as far. Acoustic telemetry works from anything between a few meters to more than a kilometer in distance. So the detection range is a completely different one. With that, you need different technology. And obviously the price is a bit pricier to start with. If you look at basic transmitters, they start at around, and I'm sticking with euros here, it's about 280 euros per piece. And they last from, you know, it depends on the programming and the model that you're choosing. But then you can also attach sensor IDs, sensor information to these transmitters. So you not only know the ID, so which individual you are tracking, but you can also see the temperature, acceleration, predation events happening with some of our transmitters, depth of the animal, where it has been, when it has been detected, and so on. And then all the real-time data that you can get. So, and then you've got receivers. The most basic ones are probably starting at around 1,700 euros. And then they last for about a year. And then you re-battery them with a battery that you can then exchange yourself, and it's like 29 euros a piece and it lasts for another year. So once the infrastructure is in place, it's fairly easy to maintain it over a long period of time.
Okay, so thank you very much, Andre, for this very interesting theme and very interesting technologies. In the audience, do we have some more questions? If not, I suggest Andre shared his email address, and I guess he is available also throughout their websites. So
yeah,
we
absolutely.
can slowly, yeah. Thank you very much, Andre. We can slowly move to the second presentation. It is about adaptive management to coral reef systems in Kenya, addressing land-based pollution problems in marine waters, presented by Cornelius Okello.
Can you hear me? Can you hear me?
Yes, we can hear you.
Let me share my screen then.
Please go ahead.
Sorry, just 1 minute. Share. Can you see the screen?
We can see it.
Perfect.
And we can hear it very well.
Great. So let me begin just briefly introducing myself. My name is Cornelius Okello. I am a lecturer at Machakos University and also an associate at the Institute of Climate Change and Adaptation and ERACOMA. What I'm talking about today is a project that was funded by National Geographic Society that was done a few years ago. We've just finally finished, finally finished analyzing the results and are ready to go to publish it. So it's basically looking at how land-based pollution would impact marine ecosystems, and we took our coral reefs as our indicator species. So quickly, I can just give you some background. I think all of us are aware about the importance of coral reefs and how diverse the ecosystems they are in the universe or on planet, housing about tens of thousands of marine species. So they provide incredible value not only to human beings but also to wildlife in terms of habitats, nurseries, etc. We see that about a third of our marine fish species will live part of their lives in coral reefs. So they now support our fisheries endeavors. They also protect our shorelines from storms and are a billion-dollar industry in terms of food and job creation for people around the world. So what threats are these coral reefs facing? First of all, we have got our big elephant in the room today when we talk about climate change, increase in temperature, increase in greenhouse gases in the atmosphere, which then lead to acidification of the ocean, does pose a threat to corals, specifically because corals are extremely sensitive to temperature and pH. So this can lead to incidences of coral bleaching, where our corals die, leaving behind just the exoskeleton. We also have threats like overfishing. A lot of overfishing activities have been seen to pose a threat to corals in terms of reducing even the coral abundance and not just their population. And finally, we have also the threat of pollution. And pollution here, we're looking at it not in terms of chemicals, but more in terms of nutrient enrichment. And nutrient enrichment will come mostly from land-based sources in form of from raw sewage or from runoff from our agricultural sites. So for the purpose of this study, we really did focus on nutrient enrichment. And this, as we see, can have a myriad of effects on our coastal system. When we have just enough or moderate nutrient, then it becomes beneficial. So because it increases primary production, the polyps, the polyps in the corals, the phytoplankton in the water column need this kind of nutrients. And nutrients here, we're talking about things like nitrates, nitrites, phosphorus, etc. And with this, then you see our fish population will also increase. However, when there's an oversupply of these nutrients, and we expect to have detrimental impacts. So what is considered enough nutrients would range. There's a ratio that has been calculated that was found to be between, when you look at nitrogen phosphorus ratio, would have anything between 4.3 to 1 to 7.2 to 1. So anything beyond this, and if there's ever an imbalance, then we start noticing losses in terms of coral biomass. We start seeing malfunctioning of algae, coral bleaching, or in some instances we get algal blooms, which then choke our coral reefs. Now, we've got a lack of phosphates also causes a stress. So what we want to do is have this perfect balance between nitrogen and phosphorus. So not too much or not too little. Now, in areas where there's over-nutrification or too much nutrient enrichment, what we expect to see is increased primary productivity. So phytoplankton biomass will increase. Well, phytoplankton biomass increases, then we expect to see reduction in water clarity and incidences of reduced oxygen. So we start seeing hypoxic or anoxic situations, which then affect coral reefs. When this happens, then we start seeing changes in trophic structures, even trophic interactions, not only between phytoplankton and zooplankton, but also benthic communities, and here we include corals. Also, we expect to see harmful algal blooms when we've got too much nutrients. And there have been incidences where, because of macrophytic vegetation overgrowing due to the excess nutrients, then coral reefs tend to be choked. So this will have an impact also on our fisheries. Now, what we're saying basically in a nutshell is that in a situation where there's too much nutrients or there's over-enrichment of nutrients, then we will see a reduction in biotic diversity in the ecosystem, because very few organisms will be able to survive in these conditions. So with this background, what we set out to do in this study was to understand how nutrient quality and quality would affect marine ecosystems. But that was too broad. So we we zeroed in on coral ecosystems specifically as our indicators. And here we're looking at nutrients that are land-based, nutrients coming from the mainland. Our study area was basically the marine protected areas that are found off the coast of Mombasa. Here we have our Marine National Park and our Marine National Reserve. And why it was interesting for us was because in as much as these areas are protected and human involvement is really minimal, we have a creek, which is the Mtwapa Creek to the north and the Chuda Creek to the south. Now we have got activities that are occurring within these two creeks that are leading to waters being discharged into the marine park, and wanted to see how is this affecting it. Now, because of lack of funding and time, we focused more on the Mtwapa Creek. And why we focused on the Mtwapa Creek is here we have a prison called the Shimolatawa prison that has been found to be releasing raw sewage into the Mtwapa Creek. The reason being that they had a wetland, it's a wetland that was supposed to be cleaning the wastewater that has not been functioning for many years. So we end up having raw sewage. So we were curious, how would this happen? So in this study area, we picked 2 study sites within the creek to understand the quality of water that was getting into the open ocean. And then we picked 2 sites in the marine park and in the marine reserve that were rich with corals. And Kanamai to the north was picked as our control site. And there's a lot of community involvement in this area that conserves the ecosystems there. So what we basically did was we collected water samples where we measured your basic parameters: water, dissolved oxygen, suspended solids, pH, temperature, etc. And we also wanted to look at the primary productivity. So we looked at chlorophyll A, how much chlorophyll A was in the water samples. We also looked at the amount of nitrates, nitrites, and phosphorus. So we wanted to understand the water quality that was in the creek as well as the protected areas. The other thing we did was we also looked at the coral health. Now this was being done, this was part of a monitoring program that has been ongoing, that is being led by KWS, where every month they use the quadratic methodology, where they count the number of healthy corals in a given space. So what we were looking at specifically was looking at the health in terms of density, color, biodiversity, and presence of also fleshy algae. Now, so far, our results were quite interesting, where we noticed, first of all, that the temperature was higher towards the creek, and the temperature reduced as we went into the open ocean. However, the temperatures that we found were not enough to have an influence on the coral health, because that temperature is what you'd expect corals to thrive. The same was also found for pH and salinity. However, we found that the amount of total suspended solids, chlorophyll A, phosphorus, and nitrogen, and nitrates and nitrogen tended to be higher than what we'd expect. So we figured that the availability of these nutrients, chlorophyll A was telling us that the primary productivity in this water tended to be higher than what would be expected in other waters, meaning that the nitrogen, the nitrates and nitrites, and the phosphorus that was in the water was causing a lot of productivity, which we have, as we've seen in the background information, does have an effect on the benthic communities. So the total suspended solids across the oil stations were higher than recommended standards, suggesting that this would be a contributing factor in the deterioration of coral health. We also saw that the nitrogen, the nutrient load in the water was greater than the amount needed to maintain 50% of coral reef coverage, meaning that the excess nutrients that were coming in from the creek would be a major contributing factor to the coral health, of the communities in this particular area. Then when we analyzed the data on the coral health, we used a methodology that was developed by Kawaka et al., who work for Kodio, where they classified corals into three groups: unhealthy, fair, and healthy, where unhealthy corals would cover 15% of the total area would be live corals, and more than 21% would be algal cover. For fair, it would be between 50 and 30% live coral cover, and between 6 and 20% algal cover. And then healthy corals would have more than 30% of live corals and 0 to 5% algal cover. So in our results, we found that majority of our corals were either fair, where we found some areas that got 17% live or hard corals, while the soft corals were less than 2%, and the macroalgae were more than 22%. So this told us that our coral reefs were either fairly healthy or unhealthy. So from this, we find that based on our results, nutrient quality and quality were found to be higher than recommended standards by international communities, meaning that they're a limiting factor to coral health, telling us that from the results, we saw that the nutrients were highest in the creek, and as we went deeper into the marine reserve and the marine park, they tended to be lower because of more mixing from ocean water, but still the nutrients within the marine protected areas was higher than what was recommended. And this meant that the coral health was being impacted, meaning it was fair and healthy. We also observed that based on our observations and anecdotal evidence, that it would be misleading to say that the point of pollution was specifically from the creek. It has been observed and also corroborated by people around the area that all the developments along the coast, despite there being a ban, despite there being a restriction of disposing sewage or wastewater into the ocean, some of the hotels, some of the residential areas were still doing that in the cover of night. So this means that we need to go back in there and really assess and find exactly where the source is, right? And the second thing is that we also did not look at Tudor Creek, which could have been seen to be a major contributor to this, because we have the general hospital there that is also releasing that is also releasing waste into the creek. So our conclusion is that if we are to engage in any serious conservation efforts within the marine park and the marine reserve, we need to consider land-based pollution as part of a holistic and integrated coastal zone management approach, instead of just concentrating on only what is happening in the marine space. We also need to consider what's happening in the landward side, and make it part of our conservation efforts, so that we can be able to curtail or reduce the amount of nutrients that are being discharged into the marine environment. So unfortunately, my co-authors couldn't join us today, but I'd just like to mention them. We had got Dr. Margaret Awor, Dr. Arthur Chuda, Nancy Kodwor, Josephine and Gilbert, both from Kemfrey. Also, would like to give a special thanks to Kemfrey, who helped us with our data analysis, especially for the water quality. The Kenya Wildlife Service, who basically helped us a lot with the data collection and give us access to the marine park, and National Geographic for basically providing funding for this project. Thank you very much.
Thank you very much, Cornelius, for this brilliant presentation. Any question? I see Hoke is raising hand.
Oh, sorry. Margaret has told me she's here. I said she isn't here, but she's around.
Yes. Yes. Okay, go ahead with your question.
There was a clapping hand.
Okay.
I was applauding. But,
sorry.
But no, very excellent talk. I really enjoyed not only the content, but also the style. It's really nice listening to your talk. Yeah, is there any way in terms of mitigation or implementation of measures that you could see of addressing this issue? Because I mean, it's like a worldwide issue. It's not only in Kenya. We have the same problem in Germany as well. In the Baltic Sea is polluted so badly. But I think there's very little being done about it. So you think it's more easy to address it on a local level? So contact the prison, try to find mitigation measures, or does it need to be like a national or regional initiative?
In my thinking, I think it's both. It has to be a local issue and has to be addressed from the national level. From the national level, we have policies that do govern wastewater management, but there seems to be a gap in the implementation of these policies. So we need to be more careful with the implementation of it. But ultimately, I still do believe that the answer to it would basically be integrating, not having this silo kind of approach where we are managing our marine ecosystems in one side, and then we've got an entirely different organization managing our land-based activities, especially since they are being linked. And if you're looking at water, this is just looking at the marine ecosystem and what is at the coast. When you're looking at some of these rivers like the Tana River and the Athi River that come all the way from the inland, the activities happening up there will have an impact on the ocean. So we still do need to have this, we know we need to talk to each other and not just work in our silos. I think that for me would be a more worthwhile endeavor.
Yeah, thanks for sharing. I think you're a point on that we need to have the whole picture in mind when trying to make changes. Thanks a lot.
Thank you.
I see Juliet raising hand.
Yes, thank you so much, Okello. It was a very interesting talk, and I have a question. Did you check on the current dynamics, or the water flow from the creek? How does it go? Does it go southwards or northwards? And does that affect the transport of the nutrients further to Nyali? And if you say that it's urban, so there could be other sources of pollution from sewage disposal. And do you know like the points where that the source could be coming from, in between or also through the creek?
I thank you. That's actually a very good question. When we started the project, we actually had a partner on board who was going to do some sort of mapping using heat and seeing how the currents move and where they distribute etc. Unfortunately, as the project progressed, she was not able to continue, so she dropped off. Now, we used Kanamai as our control site, so to see that now that became our way of looking at the flow of water to see what the concentration looks like in Kanamai. And from our results, we saw that Kanamai was not that much, didn't have that much concentration as opposed to Nyali. Now, this might be because Kanamai is a bit farther away, but we know we may not really get there without further investigation. In terms of sources of pollution, when we went in there, we were very focused on Shimolatawa prison being a point source, because even if you look at the issues, it could not only be Shimolatawa, there could be diffuse sources from upstream, because you've got farmlands upstream that probably there's erosion happening there from farmlands where nutrients from fertilizers are getting into the water. So it became, based on the scope of our study and the time limitations, we had to really narrow and focus. And that's why, as we concluded, we put in this disclaimer that we focused on this one thing, but it's not the only thing. We understand that there are many dynamics there. In fact, some people we talked to on the ground argued that in as much as we look at Shimolatawa as a point source, and I even have videos, I should have shared them, videos of the water coming from the prison into the creek. But we have hotels. Again, this is anecdotal, so we have no way of corroborating it, of people who said that they have seen hotels right next to, that are just adjacent to the Marine National Park, actually releasing raw sewage in the dead of the night. right? So you see now that it becomes tricky because it becomes also a political situation where if you go in there, you don't know whose toes you're stepping on, and you might end up, as the mafia says, sleeping with the fishes. So we focused on something, but again, there is still space for this study to be expanded. There is still a lot of there are still a lot of unknowns. What we know for sure is that nutrients are coming from the landward side. The nutrients are a limiting factor to coral health. We've made this connection. So now we need to go further and find out what is the source, where are they coming from specifically.
Thank you very much, Cornelius, for this very brilliant presentation. And I think, as Hauke said, it is a global problem in each country, in each cities. This issue is also present. So we can continue this discussion during the next session or separately, remotely, of course. Yes. But I think we have arrived to the end of this session, and this is now the time of the tea break. So thank for the presenters, and thank you also for to the audience for this session. And we'll catch up at 1 p.m. for the next session. Thank you very much, everyone. I see Hauke has put the link for the break in the message box, so you can follow it. Thank you very much.
See you there. Bye-bye.
See you.